Hey guys, Mr. T here, just doing a quick video on the idea of feasible regions. So everything that we've done so far in this topic is seeing that linear equations can be used to represent real-life scenarios that involve two variables. These scenarios, we've seen that they can be graphed on a Cartesian plane. Why? Because the axes allow us to connect the two variables if they're assigned as x and y, because the horizontal axis is the x and the vertical axis is the y. However, currently, the line equation that we draw represents solutions to the scenario that lie on the line that we've drawn. So, to illustrate that, we'll go through this scenario. Bryden Luong, must be Vietnamese, owns a grocery and buys pineapples for $2 each and watermelons for $3 each. Bryden has $30 to spend on pineapples and watermelons. So if we let x represent the number of pineapples Bryden buys and y represent the number of watermelons Bryden buys, a linear equation representing this scenario could be, or would be, well, the pineapples cost 2, so it's going to be 2 times by the number of pineapples he buys, which is x, plus the cost of watermelons, which is 3, and the number that he buys is y. And it's a linear equation, so we're saying it equals the spending money, which is 30. So that's in general form, line equation, representing the scenario of Bryden buying pineapples for $2 each, watermelons for 3, and having $30 to spend. This can therefore be drawn on a Cartesian plane, because this is in general form. Just a reminder, find the x-intercept, you make y equals 0, so plus 3 lots of nothing equals 30. X is going to be 30 divided by 2, which is 15. Make x equals 0. Plus 3y equals 30. Y is going to be 30 divided by 3, which is 10. So x is 15. Y is 10. So I can draw that. I can draw that situation on the Cartesian plane. But what does that actually mean? What does that drawing actually mean in the context of this situation? Well, every whole number grid crossing on this line represents a solution to the scenario because the equation has an equal sign. So this is a whole number grid crossing. That's a 0, 10. This is not. That's somewhere between, that's on 1, but that's somewhere between 9 and 10. This is at 2, but it's somewhere between 8 and 9. This is a grid crossing. Then that's 3, 8. And the next one would be here, next one here, next one here, and the last one is the x-intercept, which is 15, 0. Those coordinates all represent a combination of x and y that results in an exact $30 spend. So you can see here, if I buy 0 pineapples, but 10 watermelons, 10 times by 3, $30. I spent exactly $30. That's one solution. Here I bought 3 pineapples, which is 6, 8 watermelons, which is 24, 6 plus 24, exactly $30 again. 6 pineapples, 6 times 2, 12, 6 times by 3, 18. That adds up to 30 again. 9 pineapples, 4 watermelons, 9 times by 2, 18, 4 times by 3, 12. That also adds up to 30. I think you get the picture, okay? All of these crossings represent on the grid lines represent a solution that spends exactly $30. However, in real life, it's more realistic to say that you could spend up to and including $30. So to achieve this, we use inequalities such as greater than, less than, greater than or equal to, and less than or equal to. If I write equations with inequalities, now it represents a region, not just the line and the points on it. When we use these, we're going to be talking about whole spaces below or above the line. Okay? So inequalities represent regions in a Cartesian plane. Unlike line equations, which represent the points in a line only, equations involving inequalities represent whole regions on a graph. So this symbol here, greater than and greater than with the line under it, these represent respectively greater than and greater than or equal to. What do these indicate? These signs indicate the region up and or right of the line they represent. So if I was to color here, this is the region 2x plus 3y is greater than 30. If I wrote greater than or equal to 30, it would be this region and the points on the line. And then here, the beak pointing to the left, the beak pointing to the left with a line under it represent less than and less than or equal to. These signs indicate the region down and or left of the line they represent. Let's do that a different color. So everything below and to the left of the line, that is the region 2x plus 3y is less than 30. If it was less than or equal to 30, it would be this region in green and the dots on the line. All right, so suddenly, instead of just the solutions that lay on the line, we are talking about whole regions of possible solutions. Okay, hopefully that helps you out. See you in the next video.